Okay, first of all, let me show you what it looks like when it gets done. We're going to run the test, and I'm going to do truffle compile. And it's probably already compiled. It'll check between what your source is and what its compiled ABI binaries are, and determine whether or not it needs to recompile stuff. And it's looking at the dates on the files, like make. It's not actually checking the contents. So if you bring something back from tar, or you use some other thing that can set dates, be aware of that. You may have to force it to compile by touching stuff. Let's actually do that. Touch contracts employee, and let's do truffle compile. And you'll see that this time it's going to go out there and it's going to say, okay, I compiled this, it's changed. So it's not looking at the file, it's just looking at the date. Okay, now the second thing we do is we want to deploy the contract. And it's going to look at the date stamp on stuff, and then it's going to go actually out to Ganache, and it's going to say, give me back the code, and it's going to pull the code out and compare that with the binary of the code that you have compiled. And if it's not different, it's not going to charge you ETH. It's going to not load it, which I haven't changed anything, so that's good. And once you've done that, you can run tests. Now, the tests actually go out and call the not stored procedure, the smart contract. And some things to point out. For one thing, you'll notice that it has this number in yellow. That number in yellow indicates that it took that many milliseconds for it to call that particular piece of the contract. That piece is actually returning a transaction because it's changing data. Anything that changes data returns a transaction. If you have a function inside your contract that just does a calculation, then it is considered pure. It changes no data, it accesses no data, and it has no state. It's a pure function. Then it doesn't require a transaction and can be handled locally. Those are basically free as far as they're concerned. If you have something that accesses data, it will take more time. Now, if I run this same set of tests again, chances are pretty good that you'll find that there's some variability in how long things take. And we'll do it again. But every once in a while, I get one of these that takes long enough that you'll see it come up in red instead of in yellow. You'll notice that this one down here took long enough that it marked it in yellow. Every once in a while, I get one that comes up in red. Don't ask me why, but sometimes they take longer. And if they take too long, your testing environment will simply terminate the run in the middle. So if you start seeing stuff around 90 milliseconds, you know you're getting close to termination. The only thing you can do about tests and termination of tests is split your test into smaller pieces so that it will run quicker. Or optimize your code so it takes less effort to run. Remember, you're running on a system where you pay for gas, and if your contract takes too long to run, you are going to run over your gas limit for that node, which the testing nodes have 600,000 gas. The real production nodes are 473,000, something like that. So they're less. That's a very interesting concept there. But if they run too long, they terminate. So this is what it should look like if you have a bunch of successful runs. You'll notice that my tests, I have gone in and in the title of the tests, I've put in some indicator which test it is so that those are unique. If I have a slew of tests, they'll all have a unique T number so that I can identify exactly which one it is. Now, the reason I did it this way instead of should return some fancy thing and then it lists out what it is because there's two different realms here of the test. One is, am I getting back a transaction for things that I expect transactions, which is the type realm. And the other is, what is the meaning of the value? And I'm probably going to have to go and look in the code. But since I tend to set up tests where there are multiple things from a single run as a result that I'm looking for, I tend to do it this way. If you had just nice little tests with, it runs a test and it expects to get back a single name, and that's all it does. It's fine to put in, should return a person's name named Bob. Okay? and then it does or doesn't return Bob. But most of my tests don't fall into that kind of category. So, a set of tests, I have 22. This is not a complete set for this, and we're going to look at, while we're building it and testing it, why this is not a complete set. But this is a good start on testing. And now let's actually go out and start building the code. Now, the first thing that's going to happen when we build the code is you're going to want to compile it. You're going to find out that the Solidity compiler has lots of static checks, like did you use all your parameters? And since I took away the body of the code inside the functions, we didn't, so we're going to get warnings. And it's not going to pass tests because those bodies are not implemented. But let's get started with some of those things, and let's actually go build this set of code.